Alright friends, welcome back. In this video I'd like to cover section 1.5 of your textbook, and this video is going to cover a topic that not very many students typically enjoy, and that is this topic of complex numbers. So before you watch the rest of this video, what I want you to do is I want you to go down to the description, because I left a link to a video that I think it would be very helpful if you watched it first. If you can't find the description, then just go to YouTube and type in "imaginary numbers are real." You're looking for a video made by a YouTube channel called Welch Labs. And I just want you to go ahead and watch the first video in that series he made. Again, the title is called "Imaginary Numbers Are Real." It'll say Part 1, an introduction. That is a video that just gives a very, very good introduction to the world of complex numbers and imaginary numbers. And you can watch as much of that series as you like, but I especially want you to watch that intro video because, again, it gives you a really nice introduction to what the topic of this video is going to be, which is complex numbers. So I want to go ahead and dive into that here really quickly. And so whenever you see this word complex, I feel like a lot of people get it into their minds that complex in this case is going to be synonymous with complicated or with hard or challenging or something. Well, that's not really the context that we want to go with, because complex here means more like an apartment complex where you have this building made up of a bunch of different parts or apartments, right? So that's what this word complex is going to mean in this context, is that we have numbers here that are made of parts. And so specifically, we have two parts in a complex number. So we have the first part, which is right here, the A. We call that the real part of the complex number. And then we have this other part right here. We call this the imaginary part. Okay, so that's why we call these complex numbers, is because they're made of these two parts right here. And of course, we have that classic imaginary unit. We have the number I here, and I's definition is that I is the square root of -1, or in other words, it's the only number out there that if you square it, you end up with -1, okay? And so what I want to do in this video is I want to do a couple of problems where I is going to show up in your problem, or it's going to show up in your solution. So let's go ahead and take a look at that. So I is used to simplify radicals with negative radicands. So in other words, it's used to simplify radicals where you're going to find a negative number underneath, okay? And it's super easy to deal with negative numbers underneath your square root symbols. All we want to go ahead and do here is scratch out the negative that we see and then write an I out front, okay? So we're going to scratch out the negative, put an I out front, scratch out the negative, put an I out front, and even on this third one, scratch out the negative, put an I out front. Okay, so anytime that you see a negative under the square root, that's what I want you to do. Scratch out the negative, put an I out front. Because when you scratch out that negative, what I mean to say here is that we're trying to take a look at this number under the square root as a positive number. So the square root of positive 36 is how we're looking at this. So that's going to be I times whatever the square root of 36 is, and of course that is 6. And we would typically go ahead and write that as 6I. Okay, so that's going to be our solution for the square root of -36. In the case of square root of -64, when we scratched out that negative, again, we just want to take a look at this as the square root of positive 64, and that, of course, is going to be 8, which, of course, would mean we're going to write our solution as 8I. And then finally, here in this last example, we have the square root of -12. Again, we scratched out the negative there so that we could take a look at this as the square root of positive 12. And 12 is not a perfect square number, but we can break up 12 into 4 times 3. So if we take the square root of 12, that means we're taking the square root of 4 times the square root of 3. And the square root of 4, of course, is 2. So 2 square roots of 3 is how that radical would reduce. And, of course, we have that I chilling out in front. Now, as far as how you would write this number, one of the ways that we do not want to write this number is in this way, where we would have 2 square root of 3 times I. And the reason that we don't want to write it that way is because we might get confused and think that I is living under the square root, which is not what we mean to say at all. Another option would be to just go ahead and keep that I in front, but then this looks a little bit awkward because we typically always want to go ahead and write the integer before the variable like this and say 2I. And so because we don't want to write it after the square root number and we don't want to write it before the integer 2, we actually go ahead and just write it like this, where we say simply 2 times I times the square root of 3. Okay, and so that gives us a really easy way to go ahead and think about how to figure problems out whenever we are taking the square root of a negative number. Okay, I want to go ahead and take this over to the calculator here really quickly because if your calculator is in the proper mode, it can actually be used to check all of these answers here for you, okay? So to change the mode of the TI-84 here, what we're going to go ahead and do is click this mode button that I have highlighted over here in red. If you click that open, it's going to bring you up to a big menu here, and what we want to do is use our down arrow button until we all the way get to this row right here, which is going to say real in the first part, and it's going to have that highlighted background because that means that my calculator is in the real number mode. I just want to go ahead and use my right arrow button to select the A plus BI mode. That is your complex number mode here. And then once that background is lit there, we can go ahead and quit out of this menu by pressing second mode, and that'll take us back to our calculation screen, and you can see up at the top it says A plus BI, meaning that I am in my complex number mode. If you were in the real number mode and you tried to type in something like the square root of -36, like in our first example, it would give you an error. But because we are in complex number mode, if we press enter here, it's going to tell you that the answer, of course, is 6i. Okay? We could do the square root of any negative number we want. Like in the second example, we did the square root of -64. That gives us 8i. And the unfortunate thing is that when we reach for that third example, the square root of -12, it will do it for us, but it's not going to tell us 2i times the square root of 3 like we got. Instead, the only thing that the calculator is going to be able to do is give you a decimal and then just say I at the end. But we could still check our answer by typing in what we got. Okay, so if I type in 2i square root of 3, I'm going to compare it to the previous line. So the way that you type in an I, of course, is you go ahead and press the second button, and then you want to follow that up with pressing the decimal point button because you can see that little I symbol in the corner there. So second decimal point will bring up an I for you, and then just the square root of 3, and press enter, and you can see that the exact same decimal is going to be the solution for the square root of -12 and for the answer that we got, so we know we got the right answer. Okay, so the calculator, assuming that you're in the right mode, can check any one of these answers for you in this set of notes. And so the next type of problem that we're going to go ahead and take a look at is doing all of the operations with complex numbers. So adding and subtracting two complex numbers, multiplying two complex numbers. We're going to review that here a little bit. And also later on, dividing complex numbers. And these would be the steps that we want to go ahead and take a look at for being able to do that. Just real quick before we move on to that, when I say in step number 1, when I say fix any radicals with a negative radicand, what I mean is doing that whole process of what we just did, which is scratch out that negative and put an I out front. Okay, and so let's go ahead and take a look at all of the odd examples here in this set of notes, starting with number 5 here. So if we were to go ahead and take a look at a problem like this, instinctually, I think what you might think to do is do distributive property, and that's exactly what you want to do. The nice thing with dealing with complex numbers is that they work in the way that you think that they will. Okay, so if you see that you could do some distributive property, that's exactly what we'll go ahead and do. So we'll distribute that 3 in. We're going to say 15 plus 6i as that first complex number, and you'll notice that we use some parentheses to say that I'm dealing with one complex number minus a second complex number, which you notice in that second one here, it's not written in the form that we prefer. It's written in that form of bi plus a, but remember, we don't want that form. We want the a plus bi. So I'm just going to go ahead and flip that around here and call that -3 plus 4i, just so we can go ahead and look at that as a complex number. And then when you go ahead and subtract two complex numbers, you're just going to go ahead and subtract the real parts and then subtract the imaginary parts. So our real parts here are 15 and -3. Just keep in mind that we are subtracting these two complex numbers here. And so if you wanted to think about it in this way, you could, where you could distribute in that negative. You could absolutely think about it this way. So matter of fact, let's just go ahead and do that. Distribute that negative inside. We would end up here with 15 plus 6i, dropping those parentheses because there wasn't a negative in front of those. But then, let's see, changing the sign of everything in that second set of parentheses, we would have a +3 minus 4i. And then from here, we just want to go ahead and now combine some like terms. So we're going to combine our real parts. So that's going to be 15 plus 3. That's going to be 18. And then after that, we're going to combine our imaginary parts here, right? So your 6i minus 4i, of course, that's going to give you plus 2i. Okay? And so we did get a complex number as our solution whenever we subtracted these two complex numbers here. And again, if you reach for that calculator, it can check your solution for you. So let's check that, right? So we're going to clear all this out. 3 times 5 plus 2 times I. Remember, second decimal point plugs in the I. And then minus, parentheses 4 times I, and then -3. And if we press enter on that, it's going to give us the exact same solution that we just got on our notes here. So again, use that calculator to check all of your solutions on these problems to make sure you did them right. Okay. In this next one, in number 7, we have a couple of negatives under some square roots. So remember how we deal with these. We just scratch out the negatives and put an I out front. Scratch out the negative, put an I out front. So what we have here is I times the square root of 5 times I times the square root of 10. Okay, and because multiplication is commutative, what we can go ahead and do is multiply these i's together. So I have I times I. I'm going to go ahead and write that as I squared. And then what we're going to do is multiply these square root numbers together. So square root of 5 times square root of 10. If you were to take regular 5 times regular 10, that would just be 50. So the square root of 5 times square root of 10, of course, is the square root of 50. Okay, and I'm going to go ahead and work with the definition of I here because, again, if you may remember, we said that I was the number that if you square, it's always going to be equal to -1, and I definitely see that I have an I squared here, so instead of saying I squared, I'm going to trade that out for -1, and then I'm going to go ahead and simplify the square root of 50. Okay, so 50 you could break up as 25 times 2, and so if you're taking the square root of 50, that means you're taking the square root of 25 times the square root of 2, and that, of course, would just simply give you 5 times the square root of 2. And so if you go ahead and multiply -1 times 5, of course, you get -5 times the square root of 2. And you might be asking yourself, well, where the heck did I go? I thought we were dealing with I in this video. Well, what we're seeing here is that when you take the square root of negative numbers and you multiply those together, because I times I is -1, that it completely eliminates I from the problem. And this is something that, again, you can go to that calculator and check for yourself here. So if we were to go ahead and do the square root of -5, arrow out of that square root to multiply times the square root of -10, then it would go ahead and give you this decimal number as your final answer. But remember that our answer was -5 times the square root of 2. And if we go ahead and press enter on there, you can see that those decimal numbers perfectly match up. So we know we got the right answer. Okay? So again, just a couple of calculator tricks to try to build some confidence with you. Make sure you get the right answers here, okay? Now, on number 9, this would be one that you can use FOIL method for if you really want to, because we do have a 2-term times a 2-term, but if you notice, the form of what I gave you here looks exactly like u plus v times u minus v, okay? And so, if you have that, remember that this is something that we call the difference of two squares. And this is one of your special product formulas, and also happen to be one of your special factoring formulas. This is something that has come up time and time again in our course here. So definitely a form that I want you to be on the lookout for. If you have this, then this is always equal to u squared minus v squared. Okay, and so that's no different here. Playing the role of u, it looks like it's simply just 3, so we're going to go ahead and say 3 squared minus, playing the role of v, of course, is 5i squared. Okay, and so let's just talk a little bit about how that would simplify here, because 3 squared, of course, we know is 9, but 5i squared, right? Well, 5 squared is 25, so we're going to go ahead and say 25 here, and I squared, remember, that is just simply going to be -1. Okay, so if we go ahead and simplify this, we're going to get 9 minus 25 times -1, and of course that would just simply change this times -1. That would change this to a plus 25, in which case 9 plus 25, that's going to give you positive 34. And yet again, we see here that we end up with an example where I doesn't show up in our answer at all. And just to confirm that for you, let's go to the calculator and let's type that in, right? So we've got 3 plus 5i times 3 minus 5i. And if we press enter on that, it gives us 34. So again, when you multiply two complex numbers together, you're going to get a real number. Okay, so that's pretty interesting. Moving on here, what if we raise a imaginary number to a higher power? How do we do this? Well, again, because everything in that group, the 2 and the I, everything in that group is being raised to the third power, we think about this as each individual being raised to the third power, okay? And so 2 to the third power, of course, is just simply going to be 8, but I to the third power, how could we think about that? Well, remember that you could break up a base raised to an exponent, right? If I break up I to the third power as a single copy of I times I squared, because remember, if you have like bases, you would just add those exponents if you're multiplying, right? Well, I is just going to simply be I, but I squared, remember, is -1. So this is really going to turn into 8 times -1, or in other words, -8, and then we would say simply I there. And again, you could check that in the calculator here too. If I were to go ahead and do 2 times I raised to the third power, it would tell me -8i. Okay, so again, we're checking our answers. We're building some confidence with this stuff. Always use the calculator to check your work. All right, in number 13, we have a complex number in the denominator. And remember that the definition of I is that it's the square root of -1. So really what we're saying here is that we have 1 minus 2 times the square root of -1. We never like to see the square root in the denominator, and so for that reason, we never like to see I in the denominator either. So we're going to have to do some work to remove I from the denominator. And so in order to do that, what we need to do is multiply this complex number times its conjugate, because you just saw in one of the previous examples in number 9, if what you have is something like this in the denominator, we're going to introduce this, because whenever we do the work, we see that we end up with just a simple real number without I in it. And so that's how we're going to get rid of I in these examples. We're going to introduce times 1 plus 2I. Okay? And again, if we do that, the difference of two squares is going to kick in. I'm not going to write out the whole formula here, but that is going to be 1 squared minus 2I squared. And if you do the math on that, just like we did in the previous example, what this is going to turn into is going to be a simple 5. Okay? And remember that whatever you do to the bottom, you also have to do to the top. So I'm going to go ahead and multiply the top times 1 plus 2I as well, in which case you would just go ahead and think about that, of course, with distributive property. Okay, so 8 times 1, of course, is 8, plus 8 times 2I, which is going to be 16I, and we end up with 8 plus 16I all over 5, and you might want to call that your answer, but remember, always check this in the calculator. So if we go to the calculator and type that in, we have an 8 on top, and then we have a 1 minus 2I on bottom. Then this is going to be something that if you were to press enter at this point, it's going to give you a decimal. So I'm going to try to keep my fractions in the mix by now going off to the side of it and pressing math button, which is right below alpha. And you'll notice the first item in that list says arrow frac. That means maintain my fraction, right? So if I press enter on that, then it's going to give me this answer right here. It's going to give me 8 over 5 plus 16 over 5I. And if you look at our answer, we did end up with those same numbers, but it was written in a different form. Just remember that what the calculator is doing is they're taking the common denominator that we have it written as, and they split it up so that both terms in the numerator, the 8 and the 16I, the calculator is saying that we're going to take that common denominator of 5 and split it up amongst these. And then we're just going to put that big plus sign in the middle. And you notice how else the calculator put this out is that instead of I being on top of the fraction, 16 over 5, they put it next to it. They put it on the side. And that would actually be equivalent to having it in the top there. So again, the reason that the calculator is spitting this form out is because this is something that is very much of the form A plus BI, where you can immediately tell here that playing the role of A is simply going to be this fraction, 8 over 5, and playing the role of B, of course, is going to be this fraction, 16 over 5. So the calculator is programmed to always spit out the answer in that form so that you can always pick out what's playing the role of A and B in that way. So as long as you're able to look at what you have in the calculator and match up to what the answer you got is, you're perfect and you're ready to go. Okay, and number 15, this will be the last example of this type that we do here in this video here. We are going to go ahead and square that complex number in the denominator. Now, one thing I never want to see anybody doing is distributing that exponent of 2 to everything inside, because we don't have two separate things in the denominator. We have one thing in the denominator, and namely that one thing is the difference between these numbers. And so how we would go ahead and handle this is we would go ahead and split this up. We would go ahead and write 2 copies of that complex number and FOIL it out. That's one legit way of doing this. Or one other thing that we can do is recall our special product formulas, because remember, we had a product formula that looked like u minus v quantity squared, and if you remember, this formula said that this was always equal to u squared minus 2 times u times v plus v squared. So again, you could write 2 copies of this and FOIL it out if you don't remember those product formulas, but I'm going to go ahead and apply the product formula here because it's going to be nice and simple. Playing the role of u is going to be 4, so I just simply would just want to go ahead and take a 4 squared to begin, and then minus 2 times u, which is 4, times v, which is being played by 5i here. Okay? And then I simply want to go ahead and add on my v squared, which is simply going to be your 5i squared. Okay, so we'll work that out and figure out what that's going to be in the denominator. We still have 3i in the numerator, so let's go ahead and continue to work here. So the 4 squared, of course, is going to make 16, and then the negative 2 times 4 is going to make 8, times 5, that's going to give us a negative 40i. Okay, and then what we're going to have here is 5i squared, and if you do the math on that, that's going to give you a negative 25. Okay, and again, this is all still over 3i here. So if you go ahead and simplify this further, 16 minus 25, that's going to give you a negative 9 minus 40i in the denominator and a 3i in the numerator. Now, remember that we never ever want to see your I in the denominator. So it would be at this point that we would go ahead and multiply times the conjugate here, which to save time on the video, I'm going to go ahead and forego here. You can work that out yourself. It would work the exact same way as what we did in the previous example, but I will go ahead and share with you, if you give me a moment, what the correct answer is going to be here. So let me type that into this calculator here really quickly, and then we'll share with you what that answer is going to be. So if you do this all correctly, you are going to get some doozies of answers here as your final answer. There are going to be some very big fractions here for you, or at least some very confusingly looking fractions here. You actually get 120 over 1,681 minus 27 over 1,681i. Okay, so again, just to prove that to you, let's go ahead and do it in this calculator, right? So let's go ahead and type in that 3i in the numerator. This would be a very, very challenging problem here. 4 minus 5i all squared in the denominator, okay? You can see how ugly these decimals are. If I go ahead and do the math fraction enter here, you can see that my fractions here are going to get very involved. But the good news is the calculator can be used to check these answers for you. So even if you have a challenge problem like this, it is going to be something that you can continue to do. All right, so that's just a little bit about simplifying complex number operations here. What I want to do now is go ahead and move on to the topic that we were discussing before we started discussing complex numbers, which is solving quadratic equations, right? We took a lot of time in 1.4. We took 2 videos for that to talk about your various methods for solving quadratics. And so in this video specifically, I'm just going to go ahead and stick to quadratic formula to solve these. And just remember that in order for quadratic formula to work, you do need a special form. You need ax squared plus bx plus c to be equal to 0. If you've got that form, then you can go ahead and apply quadratic formula, which of course says x is equal to the opposite sign of b plus or minus the square root of your discriminant, which is b squared minus 4ac, all over 2a. Okay, so while you could use other methods like maybe factoring or completing the square in some of these examples, I'm just going to go ahead and straight up apply the quadratic formula to each one of these. And so if we go ahead and take a look at maybe say number 17, since we're doing the odds here in the video, let's go ahead and pick out what's playing the role of a, b, and c. You notice that we have the special form going on here, so pretty easy to tell that playing the role of a is 4, playing the role of b is positive 16, and playing the role of c is positive 17. Okay, if I go through and calculate my discriminant here really quickly, b squared minus 4ac, then that is going to give me 16 squared minus 4 times a, which is 4, times c, which is 17. And I've got some bigger numbers here, so I'm just going to go ahead and let the calculator do all the heavy lifting here, right? So 16 squared minus 4 times 17. And what I get is actually a negative number, right? So I get a negative 16 here for my discriminant. You might remember from the 1.4 notes, if I go back to those here really quickly, we talked about the discriminant of your quadratic formula here. So if I scroll down, what we said before is that if your discriminant happens to be less than 0, then what you will conclude is that you have no real solutions. And that is a good conclusion because we aren't going to have any real solutions here. But remember that if you were to continue with the quadratic formula here, the discriminant is something that you would be taking the square root of. Okay? And so we can see here that we're taking the square root of negative 16. That's why we said before that if you have this, then you're going to conclude no real solutions because you don't have any real solutions. But what we know now is that we would have some complex solutions. So instead of concluding no real solutions from now on, we're going to conclude that we have 2 complex solutions, and we're actually going to do the work to figure out what those complex solutions are going to be. Okay? And so let's actually go ahead and finish up the problem here. And if we have the square root of negative 16, remember how we deal with that. We just go ahead and scratch out the negative and put an I out front. And then the square root of 16, of course, is 4. So this is going to be 4i as our discriminant. Okay? I always like to do that first because now when I go ahead and actually apply the rest of quadratic formula here, that's going to be x is equal to the opposite sign of b. So our b is positive 16. So the opposite sign, of course, is negative. Plus or minus the square root of our discriminant. Well, we already did all that heavy lifting. That's just going to be 4 times I. And then this is all over 2 times a, which is going to be 2 times 4 for us, or in other words, 8. So this is going to be negative 16 over its own 8, plus or minus 4i over its own 8. Again, just kind of splitting up that common denominator. And we're going to see here that negative 16 divided by 8, of course, is negative 2, plus or minus 4 over 8 is going to give us the fraction 1/2, and then we're going to tack that I on to the side here. So there we go. Those are our solutions. Now, the calculator is not going to be able to solve this equation for you, but it will give you the ability to check your solution. So that's what I want to go ahead and do now. Keep in mind that what we've written here are 2 solutions. We've written 2 different solutions using that plus or minus as shorthand. So my 2 solutions are negative 2 minus 1/2i, and then I have negative 2 plus 1/2i. Okay, I am going to check both of those in the calculator right now using the whole store function that we've talked about in previous videos. So if I go ahead and type in my first solution, -2 minus 1/2 I, I'm going to store that into the calculator, and because this is in complex number mode, it's going to be able to do that just fine, and it is going to give me that return value there to just confirm that it's in x. And now what I'm going to do is I'm going to type in the left-hand side of my equation, which is 4x squared plus 16x plus 17, and I'm going to see if it really does give us 0 in the calculator, okay? So let's go ahead and type that in. So we have 4x squared plus 16x, oops, and then plus 17. And if this is the right answer, it should give us 0. And it does. So that's pretty good. Okay, let's check the other solution. I'm just going to press second enter to go into the memory of the calculator to pull up what I previously typed in. I just want to change this over here to a plus. Press enter, and that's going to lock it in as x now. And then if I press second enter again, go back to what I typed in before, I press enter again, and I get 0. Okay, so both of these solutions are going to work out for me here, and that's a really quick way to check your solutions in the calculator. Okay, I'm going to go ahead and skip these other two examples, except for maybe number 21, where it's going to give you this quadratic right here. The way you would want to handle this is you would want to go ahead and expand this out, and what we have here is something that, again, looks like u minus v squared. You could write 2 copies of it and FOIL it out, but if you remember the factoring formula, then it actually gets really nice and easy here. So we're just going to go ahead and simplify this really quickly and then get it to the point where we could use quadratic formula and then just move on, right? So playing the rule of u is x, so x squared minus 2 times u, which is x, times v, which is 3, plus v squared, which is going to be 3 squared, right? And then there is the plus 4 on the other side, on the left-hand side, and that is equal to 2 on the right-hand side. And so just figuring out what this is going to be, this is going to be x squared minus 6x plus 9, and then plus 4 is equal to 2. The 9 plus 2, of course, is going to make, 9 plus 4 is going to make the 13. And that is equal to 2. And what you would want to do here is go ahead and bring that 2 over so that you get that form that we need for the green light for quadratic, which is x squared minus 6x, and then that's going to be plus 11 is equal to 0. Okay? And it would be at this point that you have playing the rule of A is 1, playing the rule of B is going to be -6, and playing the rule of C is going to be 11. Okay? So there's really no other tricks here. It's just going to be applying quadratic formula and getting your answer there. Okay? And I will go ahead and share with you what that answer is going to be in case you wanted to give this a shot on your own here. So let me go ahead and quickly find what that answer is going to be. And you should be ending up here with, one moment. Okay, so you should be ending up with here, if you do quadratic formula, you should have as your final answer x is equal to, that's going to be 3 plus or minus I times the square root of 2. Okay, so again, I'm skipping out on the work on that just for sake of time in the video here, but it would just be quadratic formula. We've talked about quadratic formula in previous videos, so you can go ahead and watch those previous videos for that. The last type of example that I want to talk about here in this video are ones where they say this. They have I, but raised to a very, very big power. We just wanted to go ahead and talk really quickly about how you would solve a problem like this, okay? Well, what we're going to do, as we do oftentimes in mathematics, is we're going to go ahead and observe a pattern, okay? So what I'm going to go ahead and do here is I'm going to go ahead and take higher and higher powers of I here. So I to the first, I to the second, I to the third, I to the fourth, and then I'm just going to go ahead and do the first 8 because I just want us to go ahead and notice a pattern that's going to emerge here. So I to the powers of 1 all the way through 8. Let's figure out what these are going to be equal to, okay? And so if you were to type these into the calculator, what it would tell you, I to the first power, well, that's just 1 copy of I. We know that. That's how exponents work, right? I squared, we also know that. That's going to be the definition of I. I squared was always -1. Okay, so that's not really surprising. But I to the third power, right? Let's go ahead and figure out what that's going to be in the calculator here. So I to the third power in the calculator is -I. And then we can just keep going here, right? So I to the third power, I to the fourth power. Oops, that was I to the 7th. Okay, so let's do I to the 4th. Press the wrong button there. There we go. I to the 4th is 1. So somehow I to the third power is -I, and I to the fourth power is 1. Really quickly, the way to see that would be, the way we broke up I to the third in an earlier problem was we said that it was I times I squared. And remember that I squared is just simply -1. So this is really just I times -1, or in other words, -I. So that's how that works out. For I to the fourth power, you could break that up as I squared times I squared, and just remember that I squared is simply just -1, so you're just taking -1 times -1, and that, of course, is +1. So that's why it works out that way. What would happen if you were to continue to type these in is you would just find that these same 4 answers are just going to keep repeating as you go throughout and take higher and higher powers of I. So I to the 5th power would be I to the 6th power would be -1. I to the 7th power, we saw in the calculator when I accidentally typed that in, that was -I. And I to the 8th power, of course, is going to be 1, and that's just going to be a cycle that's going to repeat over and over and over and over again as you start to take higher powers of I. And so we call this being a cyclic pattern, right, where I to the 1st power is I to the 2nd power is -1, and then we get -I, and then we get +1, and these are going to be the solutions that just kind of loop like this forever and ever and ever. Okay, and so what I want you to do is remember that probably the easiest one out of these 4 to get in a calculation is going to be +1, because when you multiply 1 times something, it doesn't change. Just remember that these are going to be the result of having a power of I that is a multiple of 4. Okay, so any multiple of 4 is going to, as an exponent on your I, is going to give you 1 as the result. Okay, and so up here, on number 22, it's going to say I to the 84th power, okay? So just checking 84 here really quickly. 84, that is something that is a multiple of 4. Specifically, that's going to be 4 times 21. So because 84 is a multiple of 4, I know automatically what the answer is going to be here. It's just going to simply be 1, okay? And again, what you could do is you could go around 84 times, start here at I to the 1st power, go around, that would be 4, go around a second time, go around however many times until you get all the way up to 84 if you really wanted to, but that would take a long time. Just remember that any exponent on an I that is a multiple of 4 is automatically going to be equal to 1. I think that's the easiest way to do these problems. If you look at number 23, that says I to the 31st power, and so 31 is not a multiple of 4, but what you could do is you could break this up as I to the 28th power times I to the 3rd power. Because remember, if you multiply like bases, you would add those exponents. So 28 plus 3 would be 31. And the reason that I break it up that way is because 28 is a multiple of 4. Okay, 28 specifically is going to be what you get when you take 4 times 7. And so remember that if it's a multiple of 4, then that result is just going to simply be a 1 there. And then this is going to be times I to the 3rd. And remember that I to the 3rd from before, we already figured that out. That was going to be -I. And so 1 times -I, it's going to give you simply -I as the result here, okay? So again, what you could do is you could go back to the wheel and you could cycle around it 31 times and see that you do, in fact, land on the -I in the wheel, but that would be pretty tedious and take a lot of time, okay? And again, remember also that you could be checking these in the calculator. If you were to go ahead and press in the I to the power of 84, it would give you 1. And if you press in I to the power of 31, it's going to give you -I, okay? So, again, use that calculator to check your results when you have complex numbers. Just make sure that you are in that complex number mode, and you're going to be good to go. So for all the rest of the examples and for everything else, check the notes that are in the content library on OneNote. But that's all I have for this video. Thank you very much for your attention. If you guys have any questions whatsoever, please let me know. But that's all I have for this one. I'll speak to you guys in the next one.